So in the last video, we studied about what is the meaning of similarity, and we also studied some theorems, like if a line is drawn parallel to one side of a triangle, and if it cuts the other two sides at two distinct points, then that line divides the other two sides of a triangle in the same ratio, and the converse of the theorem. So in this section, we are going to study about the similarity of triangles. When we say that two triangles are similar, so what does it mean? It means that their corresponding angles are equal and their corresponding sides are in proportion. So this is the basis on which we can say that the two triangles are similar. But we need to now mathematically find out that whenever we are given two triangles and if we want to know whether they are similar, so do we need to look out for these two quality, these two properties in totality? That means, do we need to always find out that all the angles, corresponding angles are equal, and then we need to find out whether the corresponding sides are proportionals, or suppose these are the two triangles. Now let us name these triangles. So by the above definition, that corresponding angles are equal and corresponding sides are proportional, then only these two triangles are similar. So we get, so the corresponding angle should be equal and the corresponding sides should be proportional. So if we say that these two triangles are similar, then we must have these angles, corresponding angles equal and corresponding sides proportional. And when we write that triangle ABC is similar to triangle DEF, now we need to take, we need to be careful now in writing, because the triangle DEF is same as EFD is same as FDE, but we cannot write ABC is similar to EFD. So we have to check the correspondence, that angle A is equal to angle D. So the first letter A here, it should be first letter D. Angle B is equal to angle E, so the second or middle letter here should be E. C is equal to F, so last letter here C, so last letter here should be F. Now, as we know in our class 9th, that when we studied about congruence of a triangle, so we studied that there are certain theorems based on which we can state without actually measuring each and every sides of two triangle, or without actually measuring each and every angle, uh, that two triangles are congruent if they only if we know that their sides are equal, then we can say that the two triangles are congruent. Or if we know that two sides are equal and the angle between them is equal in two triangles, then also we can say that the two triangles are congruent. The theorem was known as SAS theorem. So it is not required, it was not, when we studied congruence of triangle, it was not required that we know each and every angle should be equal to angle of other triangle, and each side should also be equal to the side of other triangle. So it was sufficient if we know that two sides are equal and the angle subtended by these two sides are also equal. So then also we could state that the triangles are congruent. So similarly, we will study here certain theorems which will help us to know whether the two triangles are similar or not. So the first theorem states that if in two triangles corresponding angles are equal, then the triangles are similar. So what it omits is the second property, that corresponding sides are proportional. So here this theorem states that just knowing that corresponding angles of two triangles are equal, it is sufficient to state that the triangles are similar. So now we will prove this theorem. So to prove this theorem, we have to prove the other part, that these two triangles corresponding angles are equal. Then we are required to prove that their sides are proportional. So we are given these two triangles and we are given that their corresponding angles are equal, and we need to prove that their corresponding sides will also be proportional if their corresponding angles are equal. And if we prove that their corresponding sides are proportional, then by definition this theorem will be proved. So let us take. So this is given to us as per the theorem that the corresponding angles of these two triangles are equal, and we are required to prove that their corresponding sides are proportional. So to prove this theorem, we do some construction. Like we find out point EFG, G on D such that DG is equal to AB. So let this be the point. And we find a point H such that DH is equal to AC. Now let us join these points G and H. So as you know uh, that to prove something, we are required to do some constructions on our own. So here AB is equal to DG and AC is equal to DH. So we have point G and GH such that DG is equal to AB and DH is equal to AC. So we have this length DG equal to AB and DH is equal to AC. Now if you see triangle DGH and triangle DEF, so we get two triangles. Now let us see these two triangles ABC and DGH. Angle A is equal to angle D. Now that is given to us. AB is equal to DG and AC is equal to DH. This is by construction. So these two triangles ABC and DGH, these are congruent by SAS theorem. So, we get ABC, triangle ABC is congruent to triangle DGH. That means that angle A is equal to triangle D. This is already given. So what we get is angle B is equal to angle G, and angle C is equal to angle H. So by proving that ABC is congruent to DGH, we get the corresponding angles equal. So angle B is equal to angle G, and angle C is equal to angle H. Now if we see triangle DGH and triangle DEF, this angle is equal to this angle, and angle this is equal to this angle. I mean G is equal to B and B is equal to E. That means these two angles are also equal. Similarly, angle C is equal to angle H and C is equal to F, which is already given. And C is equal to H. This we have proved by proving that triangle ABC is congruent to DGH. So we get this angle is equal to this angle. But what do you see? This is a line and this is a transversal, and the corresponding angles are equal. That means this line is parallel to this line. If a line drawn in a triangle is parallel to third side, then it divides the two sides of the triangle in the same ratio. So we get dg by g is equal to dh by hf, and dg is equal to ab, and dh is equal to ac. So what we prove is ab by g, or ab by d is equal to ac by df is equal to bc by ef. So this is what we will write down. So from 1 to 3, equation 1 to 3, angle A is equal to D, B is equal to E, and B is equal to G. So if we see equation 2 and equation 5, what we get here? B is equal to E. Here we get B is equal to G. That means G is equal to E. Similarly, from equation 5, 3 and 6, we get C is equal to F and C is equal to H. That means H is equal to angle F. So we have seen that the corresponding angles in these two triangles are equal. This angle is equal to this angle is equal to this, and this is a transversal. So these two lines are parallel. So in this triangle, if the line is parallel to the third side, then it divides the other two sides in the same ratio. So dg by g is equal to dh by hf. Sorry, I have corrected it. So dg by g is equal to dh by hf. but we know by construction that dg is equal to AB and dH is equal to AC. So by inputting these values in this equation, so we get so from this equation we get dg by d is equal to dh by df. How you do reciprocal of this and add 1 to both of the sides. Then again do reciprocal. You will get this. But dg is equal to AB and dH is equal to AC. Since dg is equal to AB, so we have replaced dg by AB and dH is equal to dE. This we had taken while constructing. So AB by DE is equal to DE by, so I corrected, AB by DE is equal to AC by DF. AB by DE is equal to AC by DF. So these two corresponding sides are proportional. Similarly, if we do another construction on this side, EF and DH, the same way as we have done on DE and DF, we can prove that BC by EF is equal to AC by DF. So this so we have proved that if corresponding angles are equal, then corresponding sides are proportional. Hence, the two triangles are similar. So, just knowing that corresponding angles are equal, we can state with the surety that the two triangles are similar. Now we will go to the next theorem. The next theorem states that so this theorem states that if in two triangles, if the sides of one triangle are proportional to the sides of another triangle, then the two triangles are similar. In other way, we can say that if the sides of two triangles are proportional, then their angles will be equal. Hence, the triangles will be similar. So, we have to prove the reverse of what we proved in the previous theorem. In the previous theorem, we proved that if angles are equal, then then the corresponding sides are proportional. So now we have to prove that corresponding angles are equal, and we are given that the sides of the two triangles are proportional. So we will proceed with the same logic and the same method as we did in theorem 1, that we will do a construction. So let us construct GH. G as a point which is so that DG is equal to AB and H is such a point that DH is equal to AC, and we join G and H. So we take a point G and H such that DG is equal to AB and DH is equal to AC. Now let us take a triangle DGH and DEF. So we are given that AB by DB, AB by DE is equal to AC by DF. But AB is equal to DG and AC is equal to DH. So from these two we get this equality. DG by DE is equal to DH by HF. So these two sides, the point G and H divides DE and DF in the same ratio. Hence, GH is parallel to EF. So these two lines are parallel and this is a transversal. So angle this G equals angle E and angle H equals angle F. Why? These are the corresponding angles. This is a transversal, these are two parallel lines. These are corresponding angles. This is transversal, these are two parallel lines, these are corresponding angles. So this is what I have written. G equals E, H equals F. Here angle D is common, G is equal to E and H equal F. That means DGH is similar to DEF. Hence, so we get that these two triangles DGH and DEF are similar. So if they are similar, then their sides we already know DG by DE is equal to DH by HF. Now, then this shall be equal to GH by EF. Corresponding sides of these two triangles proportional. Now from these two equations, what we can deduct? This is equation 1, this is equation 2. AB by DE is equal to AC by DF and AB is equal to DG, AC is equal to DH. That means BC is equal to GH from these two equations. That implies that BC is equal to GH. Now let us take these two triangles, this one and ABC. So you see AB is equal to DG and AC is equal to DH by construction, and we have proved that BC is equal to GH. That means these two triangles are congruent. So if they are congruent, that means this angle is equal to this angle is equal to this angle, and this angle is equal to this angle. And we already know by means of these two parallel lines, this angle is equal to this. So that means this angle E is equal to angle B. H is equal to F and H is equal to C. So that means C is equal to F. So what we have proved that these three angles are equal. I mean corresponding angles. These corresponding angles are equal. So this we write down here. So in triangle ABC and DGH, corresponding sides are equal, hence these two triangles are congruent. So in triangle ABC and DGH, what we see, AB equal DG, AC equal DH, and GH equal BC. This we have proved. So these two triangles are congruent. So this is what I have written here. If these two triangles are congruent, then their corresponding angles are equal. So this implies that, so the corresponding angles of these triangles are equal. What we already know, triangle DGF is similar to DEF. So from this we get angle A is equal to angle D, angle B is equal to G, and G is equal to E. C is equal to H. From this we get I am correcting the naming of the triangle. It is DGH is similar to DEF. The same I need to correct here. So from this, what we get? So from the similarity, we get G is equal to E, H is equal to F. So from this equation 3 and this equation 4, we get, so what we get, A equal D given, B equal G and G equal E, so B equal E, C equal H and H equal F, that means C equal F. So in these two triangles, ABC and DEF, the corresponding angles are equal, sides are proportional, hence these two triangles are similar. So in triangle ABC and DEF, corresponding angles are equal. This we have proved here. And corresponding sides are proportional. This is given. Hence these two triangles are similar. So they are similar. Hence we have proved the second theorem. Hi students. So we have studied the two theorems. One is AAA theorem. Another one was SSS theorem. Now we come to the last theorem to which help to know whether the two triangles are similar or not. This theorem is known as SAS, side angle side. So what this theorem says is that if one angle of a triangle is equal to angle of another and the side including these angles are proportional, then the two triangles are similar. So let us see in figure or diagram what does this theorem says. So we are given two conditions. One is angle A is equal to angle D and the sides including this angle are AB, AC, and here we have DE and DF. So these sides include the angle D, these two sides include angle A. So we are given that these two sides are proportional. So AB by AD is equal to AC by DF. And now we are required to prove that these two triangles are similar. So we know that two triangles are similar if their angles are equal and their sides are proportional. So to solve this equation, we do a construction. We construct and we find out a point P and Q such that dP, that is from this point to this point, is equal to AB, and dQ is equal to AC. And we join these 2 points. We mark by dash so as to know that this is our construction. We have constructed this. So now we'll see. So this equation is given, and in this equation we replace AB by dP, and we replace AC by dQ, because as per our construction AB is equal to dP and AC is equal to dF. So we will get, so from equation 2 and from equation 3, this is this is given and this is as per our construction. We get dP by d is equal to dQ by dF. That means that these two point P and Q are dividing the two sides of the triangle in the same ratio. That means PQ is parallel to EF as per the theorem that we have studied. So from PQ being parallel to EF, and this is a transversal. So we get that the corresponding angles are equal. So angle, sorry, I'll correct this. So angle P is equal to angle E, and angle Q is equal to angle F. Why? Because these PQ and EF are parallel and this is a transversal, so these are the corresponding angles, and corresponding angles are equal. So this is what we get. Now we see triangle. Now let us see triangle ABC and DPQ. AB is equal to DP, AC is equal to DQ, angle A is equal to angle D. So this is already given. So triangle ABC is congruent to triangle DPQ. Why? By SAS theorem. Side angle side, side angle side. These sides and these sides are equal. This angle subtending these two sides is equal. So triangle ABC is congruent to DPQ. So angle ABC is congruent to triangle DPQ. If they are congruent, then that means that angle A already equal to angle D, angle B is equal to angle P, and angle C is equal to angle Q. But we have already proved that angle P is equal to angle E and Q is equal to F. So from this equation and these two equations, what we get? angle B is equal to angle E, and angle C is equal to angle F, and we are already given that angle A is equal to angle D. So angle A is already given to angle D, and B is equal to E, C is equal to F, and angle A already given. This is already given. So in triangle ABC and DEF, the corresponding angles are equal. Hence, so we have proved that angle ABC is similar to triangle DEF. So our SAS theorem is proved. So through these three theorems, SSS, AAA, and SAS, what did you find? That it is not necessary that for similarity we should be given that all three corresponding angles are equal and all three corresponding sides are equal. Even if we are given that their corresponding sides are equal, that is sufficient to tell that the triangles are similar. Or if we are given that the corresponding angles are equal and nothing else is given, then that is also sufficient to tell or to prove that the two triangles are similar. Or if we are given that only one angle is equal and the sides corresponding side um, making these angles or including these angles are equal, or sorry, are proportional, then also the triangles are similar.